So we'll start with Eric for the project Filer.
All right. Hey, everybody. Hope you're all doing well, and I hope this demo goes well. We'll see. All right. Gonna share my desktop here. Okay. So, everyone can see, right? Cool.
Yes.
All right. So, let me kick this off by saying I'm a digital hoarder. So, I scan all my mail, I scan my receipts, I download email attachments. I save all my pictures from my iPhone. And, these documents are coming from all kinds of sources. And a lot of times you'll be in the middle of doing something and you'll find some documents. For example, you could be trying to find some old email, and meanwhile, you discover a utility bill. Um, so all of these documents have to go somewhere. And one thing you could do is just throw them on your desktop, but that gets pretty messy. In my case, I have a network attached storage with a giant folder structure, and I like to make sure that every single document has a home somewhere. Um, so uh, let me give you an example of how I typically uh, do my filing. So if I'm in the middle of something and I come across a document, I'll just throw it in a folder like an inbox, like this one called unfiled files, right? So here I just have four files, like a couple receipts, bank statement, and an invoice from a job I did. So then what I'll do is I will open up my basically giant file system here and then figure out a folder to put these files into and drag them, right? So you can see that this job is not a whole lot of fun, and if you're like me and you get busy, you could have like hundreds of these files, and it's very tedious to file these files, okay? So you can kind of see where this is going. So I invented an app called Filer, which is an agent which will help find homes for orphaned files. So let me demonstrate how this works. So here's the app. It's simple. There's two. Um, Let me put this in dark mode because I hate light mode. Okay. Um, there's two tabs here, indexing and filing. So indexing is where you index your library. That gives the app an opportunity to learn about your folder structure and learn about the contents of the library. So it can make intelligent suggestions later on in the filing stage. So here in this tab, you can see that last night I indexed part of my tree, which was the documents from 2025, and there are about 1,100 files there. Um, Now, the filing tab is kind of where the magic happens. And the way that works is you will drag your unfiled files onto that drop zone, and then it will populate a list of all those files, and then it'll create suggestions where to file all of those things. So let's do that. So here it is processing these four files. So you can see it already got one of the receipts, Costco here, and these are the suggestions down here. It's telling you um, which folder it thinks that this file should go in, and you can just click accept the suggestion, and it'll be put into that folder. Or if you don't like any of these suggestions here, you can just drag it into a folder. Um, so. It's not obvious here, but some of these suggestions are good and some of them are not good. So it turns out that um, this one is let's see what that is. This is the Whole Foods receipt, and it's trying to put it into healthcare, electric, whatever. It's just very random. But these other ones are perfect. So it's recommending the perfect folder for each one of these other files. So um, I dug into this a little bit, and I can kind of show you what's going on here. So let's compare like one good example and one bad example. So the Costco example, this one, if if you parse the text here, you can see this is what it looks like. However, in the Whole Foods example, when you parse the text, this is what it looks like. It's just empty. So somehow the OCR got screwed up. So if there's nothing there, it can't make a good suggestion. So like garbage in, garbage out, right? So that should give you an idea of how the app works. Now I want to show a couple more slides. This is the architecture. It's designed to be a desktop application, so nothing needs to leave your network, right? So it's a local first architecture. I'm using something called Tori as the shell, which interacts with the OS and provides a web view for the front end. On the back end, it's doing all the heavy lifting with a fast API process. And there's an indexing pipeline, which is kind of a standard RAG pipeline, walks the files, extracts the contents from various file formats, chunks them, embeds them, and puts the vectors into a database called LanceDB, which handles both dense vectors and sparse vectors for full text search. And this is the suggestion engine for the filer. It will take your file that you're trying to file and then extract the text. It will retrieve similar documents. It will craft a prompt for the LLM. The LLM will make folder suggestions, and then the human is responsible for accepting those suggestions or picking their own destinations. So I'm using just local infrastructure, SQLite, LanceDB. These are all just files on your file system. And LLM providers are swappable, so I can use Olama, OpenAI, Anthropic, Google. Okay, one final slide, and then I'll take questions. So we can actually measure the quality of the suggestion engine by doing an experiment where we take one actual file from your library and remove it and pretend like it's not in the index. And then if we were to index this, if we were to make suggestions, where would it go? And then measure the accuracy of that. So we pick a file at random from the library, and that's the true folder. We pretend the file has not been indexed yet. We generate the top three folder suggestions for it. We score the suggestions against the true folder, and then we measure accuracy at one, mainly is the top suggestion correct? Accuracy at three, basically, do the top three suggestions contain the held out folder? MRR is the reciprocal rank of the true folder. So I did three experiments here. This is the kind of baseline, the random experiment where you're just randomly making suggestions. The accuracy for that is less than 1%. And then I did two more experiments using different models. One is GPT-4o Mini, and the other is a local model, Qwen 2.5, with 32 billion parameters. And those gave very similar numbers for accuracy at one of over zero point 0.5. So a couple of observations. So AI definitely helps. You know, your accuracy at one is 120 times better than the baseline. Um, and the second thing that's kind of interesting is that the Ollama model, Qwen produces just as well as the GPT model, which is interesting, but maybe not too surprising if you think about it, because um, the model, all it has to do is kind of like basic kind of parsing functions. It doesn't need to have a lot of knowledge or anything like that. Gosh, I don't know how much time I took, but I will take questions if we have time.
Sure. Thank you so much, Eric. That's very impressive. Um, yeah, it's one of the best projects I've seen. I was just wondering if you've been able to, so you've started this project from the start of the cohort, or it's been something that you've been working on it even before the cohort?
No, I actually started it. It's kind of been on my mind, but I started it for the cohort. I haven't been working on this very long, and I have to give Claude Code a lot of credit here. So it did most of the coding for me.
Yeah, no, but still, I mean, being able to effectively use AI coding tools is also its own skill. But thank you so much for presenting. Are there any questions for Eric? All right. So, okay, Matt.
Hey, hi, Eric. Can you hear me?
Yeah.
Yeah, I love this idea for starters. And I just want to commend you for, working on this because I was thinking about working on a similar thing. Not because, not just because I wanted to work on a capstone project, but it's a problem that is dear to me. I have so many scattered photographs of my daughter that I kind of want to put together into organized folders, and I need to do it manually all the time. So I do hope that Phyla can solve that for me. It's
Yeah, images is a whole another can of worms, and I didn't necessarily tackle that, but it would be one of my to-dos is to dig into like a multimodal model and see how that handles image filing.
okay. But awesome project, just to say.
Sorry?
I say that's an awesome project. What you've
Oh,
got
thank
here
you,
is
thank you,
really
thank you so much.
so good.
Uh,
Yeah.
yeah. I was just pleased with the quality of code that Claude produced, and most of my time was just reading code. I came up with the ideas, and it did the heavy lifting, which is pretty incredible.
Excellent.
Yeah.
All right. Thank you. Over to you, Ali.
All right, thanks. So we can move on and go to the next project.